Hello YouTube Pixies, and also hello to non-Pixie people that will want to watch YouTube movies that I upload. Right, so I'm kind of getting on a bit, and I'm damned if I'm going to give up my very enjoyable hobby of electronics, right? The things that help me, obviously you can hear a fan in the background, which is that there. Find it somewhere. There we go. That sucks the fumes of the soldering iron away from my respiration system and the nose and everything. You know, as you get older, your allergies do get worse. So I've got these clip-on lenses, and another thing that you can buy on eBay. And what I do is I actually set out, when I build a project, I try and set out from the perspective of get a load of stuff done beforehand. Okay, so this here is one such thing that I did. That is a TDA 7052A amplifier. I mean, I've actually had about 2 or 3 watts out of that, and it does get a little bit toasty, so I think keep it at 6 volts. It's meant to be 6 volts into 8 ohms, and it produces 1 watt at that power. And because it gets so hot, you can't touch it when it's working. I've got a feeling that perhaps there might be some people out there doing fakes. Who knows? The fake chip industry is a big problem for electronics hobbyists. I mean, it actually does work and it sounds okay, but it does get disturbingly hot. You can't touch it, so I'm thinking of putting a heatsink around it. Now, also this is a BC 548. Okay, if I can get it to. I haven't got. I'm using my mobile phone as a camcorder, which you can do, but obviously it's not going to focus at that point. So what's happening is now, one thing I do notice what's going on by watching my YouTubes and responses. Now, there seems to be when it comes to building audio equipment, that tends to be the things that people like most, i.e. amplification. Alright, now I like to make life easy for myself, so of course this transistor, for example, is done on a piece of Vero board. Okay, and then I've soldered the leads to it, and then you see, when you're getting on a bit, it's difficult to see stuff. And also if you happen to be a teacher who wants to make things easier for your students, it's much easier for them to see. It doesn't have to be all really small. Obviously it is getting smaller and smaller all the time, and we've got this surface mount technology, which is making things smaller still. And there are chips around that I've used. One of them comes to mind is an SN76477N, and you can get these chips on eBay, and they have a 0.04 matrix. Veriboard is 0.1 inch matrix. I don't know what that. I can't be bothered to work out what that is in metric. I'm sure someone out there will know what I'm on about. So of course we're going to start by building. Well, I did try this a little while ago, which is 8 pin Dil socket on printed circuit, which I etched myself. The problem with this one is when you make solder connections to these pins, there is a problem with possibly the solder melting on the other side. And if you've glued it onto a board, which is I do an awful lot, then you won't know if the reason why it doesn't work is because the solder joint is melted. maybe some company could manufacture these for us long in the tooth electronics hobbyists. So with that out of the way, what I'm going to do is going to show how I build one of these things. Now we've got an 8-pin Dil socket, and what I want to do is, obviously we've got to break the tracks, because as it is, number 8 is shorting to number 1 if I was to solder it directly, and all the rest of them will be shorted, so we have to do track cutting. I tend to cut the track in a staggered way. So I'm just using this tool, which is a Vero spot face cutter. Basically, you can use a drill. Now I'm also doing the next one off a bit staggered, because you've only got a small amount of Vero board, and it's a good idea to spread the load. Now I can put in the chip holder socket, and using a screwdriver, which should be around here somewhere, going to bend the pins over like that. Always best to work with new Vero board, and if you've got old Vero board, which, because most of the time I'm working in a shed, like for example there's this point 2 I think it is matrix, and of course it's got corrosion there, so if I was to use this to build an amp, which I will be using, a UPC 1232, it's called a UPC or micro PC 1230H2, and it knocks out about 15 watts into a speaker, and it works off a 12 volt supply. I previously built a battery bass guitar amp with one of those, and it does sound pretty good. Now I'm going to get the vise. Whoopsie daisy. That noise you can hear is my fan, which is being used to suck the fumes away from my nose. Might have said that already, forgive me if I have. Now obviously one argument someone might present is, if you're prepared to do soldering on 0.1 inch matrix, why not do the whole circuit in 0.1 inch matrix? Well, yes you can, of course, if you wanted to, but if you get problems such as something's not working after you've built it, which ain't a lot of fun. Everything I do tends to work first time, or I can easily find out what's wrong with it, because as in this particular instance I've shown you before, all the components are spread out, so you can take voltages, and it's all on one side. Now, of course, if you happen to have someone, say an electronics club, and there's a group of younger people who are prepared to help you if you're getting on a bit, then that's good. And that, it's my soldering iron timer, because I used to forget. So now I'm going to cut so I've got 1, 2, so I can actually make a good connection with my telephone wire that's used to connect up telephones and that. A bit of sandpaper, abrasive paper I mean. This here is quite useful wire, so it's a good idea to any length you want. I mean, you know, you can always trim it down to, so I want 8 of those, right? That's 2, 3, 4, 5, 6, 7, 8. There we go. Cut them all like that. Turn it round. Cut them like that. And then the next job is stripping the ends. Okay, so I tend to give the old soldering iron a chance to warm up. This is always a bit tricky, so I'll do this side first. So what I do is I go through there like that. Actually, I need it to be a bit longer. If you can get decent wire strippers. I've got into a habit of always using a pair of side cutters and that. Okay, so what do? We go, I like to go underneath. You could put through the top if you want. It's entirely up to you. So something I'm actually in need of is a signal generator using a 555 timer. I repaired a friend's BX80 which is a BX, that's right, let me think, BX80 is a crate amplifier made by Crate, and it gives 80 watts into a huge speaker. It's specifically meant for bass guitar. And what I've got an Advance, old-fashioned 1960s Advance SIG generator, and I was testing the on the crate BX80, it's got a slave amp input, because the preamp section of the amplifier wasn't working properly. In fact, wasn't working at all. And I thought I'd check the output transistors. I mean, output transistors are a very common fault on most modern amplifiers. Part of the reason is because, for some reason, via some logic, the manufacturers push the voltage right up almost to the precipice where the actual amplifier, to the point where the transistor collectors are at maximum voltage. I mean, I suppose they might do that because they believe get more watts out of it, I guess. And so I thought the need for a 555 timer driven signal generator that works off an internal 9-volt battery was a very good idea. You don't have to worry about plugging it in, and also it's built in a cigarette box, and funny, a cigarette tin, you know. Now, strangely enough, I happen to have that very same article that I used here. So if I was to take the lid off, that's a transistor circuit built in there. Now, one of the things you need if you're repairing amplifiers, this is basically a multi-vibrator, that's a variable frequency, and the output of that is fed into a power transistor, and then that gets via the volume control fed to a couple of crocodile clips. And one problem with it I found is that even though it's got a 9-volt supply, it didn't have enough output to really push the amp slave input of the BX80 into maximum power. So I thought, right, I'll build, for the future purposes, I shall build myself one that's based on a 555 timer. I mean, what I found when you're testing amplifiers to see if they've got a reasonably good output, you don't really need a sine wave. A sine wave is useful for checking distortion. But if you know that, if you're not worried about distortion in the sense of, say, guitar amps, they don't mind being distorted. That's why the Vox AC30 doesn't have any negative feedback. So of course it sounds fantastic if you plug a guitar into it, but if you're going to use it for anything else, like discotheque for example, it would sound terrible. I don't know if anybody has ever used a Vox AC30 as a discotheque amplifier, but I wouldn't imagine it sounds very good. It would sound horribly distorted. And for general music rather than instrument, distortion is definitely to be avoided. So the actual chip socket interface is finished, but all I'm doing now is I'm just stripping the ends, so you know, there's my timer gone off, so I'll just give that another twiddle. There we go. I'm actually very excited about the number of people that subscribe to my channel. Thank you very much for all of you that do that. I think I'm up to about 700 now, a bit more than that perhaps, and I'm eternally grateful. Thank you to everybody. I'm not going to monetize my channel because this is purely a hobby, and I'm not going to ask for Patreon or anything like that, you know. I mean, quite honestly, you know, when you kind of getting on for 70, and you know, I do have a formal diagnosis of chronic fatigue. I don't want to commit myself to the obligation. I mean, there might be certain things that you're required, for example, for Patreon, or you must upload so many videos in such amount of time. Who knows? I don't know. So anyway, now there is no reason to assume that this this socket doesn't work, but if you really want to be thorough, it's a good idea to do, say, a continuity check, and also, more importantly, there's more chance of a short circuit between pins. So I'm going to, this is how I do it. I go to number 1, say, you take any one you want, like that. Someone stood on this crocodile clip, so of course it's a bit awkward to use. You can get continuity between pin number 1 and then go all the way along to all the others. If it bleeps at any point, then you know you've got a short circuit. It basically means that you've got two of the pins are joined together. Let's just go like that. That's number 2. Go like that. No continuity. I mean, you can pretty much rest assured, because you can look at it and you can see if any blobs of solder have gone across to the other side. I just like to be very precise, and it's maybe a good idea if you're a beginner. And that, there we go. There, number 4. No connection between them, no, and obviously there is continuity there. I mean, it's pretty much can't go wrong with something like this, as long as there aren't any bridges. So we've got continuity between wire number 5, pin number 5, and we can go there. Nothing. Oh, gets tedious after a while, but you can do this if you want to. If you feel that you prefer not to because it's not worth the bother, that's fine. But if you're, say, teaching a bunch of students, they might say something like, oh, the reason why my project doesn't work is because there's a short circuit on 2 of the pins. But I'm just being very pedantic here. Okay, so continue later on. Thank you for watching this element section. Okay, so goodbye, and see you in the next bit.